happens when the sun gets a little too active? When our star, the sun, becomes restless, it often results in a fascinating phenomenon known as solar flares. Solar flares are, in essence, sudden explosions of energy that occur on the sun's surface. This incredible spectacle is not random but rather the result of an intricate dance of magnetic field lines near sunspots. Imagine a tango where partners twist and turn, cross and uncross. This is what the magnetic field lines do, and when they tangle, cross, or reorganize, an explosion of energy is released, creating a solar flare. These flares are not just visually stunning, they are also a testament to the sun's immense power, releasing energy equivalent to millions of hydrogen bombs in just a matter of minutes. Yet despite their grandeur, solar flares remain a mystery, a scientific enigma that researchers worldwide are striving to unravel. Solar flares are magnificent displays of the sun's power, but they are also a scientific puzzle waiting to be solved. To understand solar flares, we need to delve into the inner workings of the sun. Imagine the sun as a gigantic, churning ball of hot, electrically charged gas, or plasma. This plasma generates a powerful magnetic field that extends far into space. The sun's magnetic field is not a simple uniform structure, it's more like a twisted knot of magnetic loops and arcs. When these loops get twisted and stretched, they store enormous amounts of energy, much like a rubber band being twisted and stretched. Now let's introduce a key player in our solar flare story, the process known as magnetic reconnection. This is where the real drama begins. When the stress on these magnetic loops becomes too great, they can suddenly snap and reconnect in a different configuration, a process akin to the sudden release of a twisted rubber band. This reconnection process releases a colossal amount of stored energy in the form of a solar flare. These flares are essentially massive explosions on the sun's surface, releasing energy equivalent to millions of atomic bombs in just a matter of minutes. They're accompanied by a spectacular light show, emitting radiation across the entire electromagnetic spectrum, from radio waves to X-rays and gamma rays. But it's not just about the light show. Solar flares also produce a surge of charged particles, known as a solar proton event. These particles can be flung out into space at nearly the speed of light, reaching Earth within half an hour of a major flare's peak. These particles can cause a range of effects, from beautiful auroras to potentially damaging impacts on our technology. The complexity and scale of these solar events are mind-boggling, but it's crucial to remember that they're driven by a process that's fundamentally quite simple. Magnetic fields, twisted and stretched, releasing their stored energy in a dramatic display of cosmic fireworks. So, solar flares are essentially the result of the sun's magnetic field playing a high-stakes game of tug-of-war with itself. Solar flares might seem distant and irrelevant to our daily lives, but they actually have significant impacts on Earth. These cosmic phenomena have the power to disrupt our world in ways that may surprise you. For instance, the electromagnetic radiation from solar flares can mess with our communication systems, interfering with everything from satellite signals to radio broadcasts. Imagine a world without GPS or internet, even for a day. Quite unsettling, isn't it? But it doesn't stop there. Intense solar flares can even cause power grid failures, leading to widespread blackouts. There's also ongoing research into potential health impacts on humans exposed to high levels of solar radiation, particularly astronauts in space. On a lighter note, these flares are the artists behind the stunning auroras that paint the polar skies. The northern and southern lights are actually the result of charged particles from solar flares interacting with Earth's magnetic field. So, solar flares, with their mesmerizing beauty and destructive power, remind us of our intimate connection with the cosmos. The understanding of solar flares is still a developing field in astrophysics. But as we march forward in time, researchers across the globe are peering deeper into these spectacular celestial fireworks. Harnessing the power of advanced technologies, scientists are now able to study these phenomena in greater detail. From high-resolution telescopes to sophisticated space probes, every tool is being employed to unravel the mysteries of solar flares. The aim is not just to comprehend these gigantic solar eruptions but also to predict them. Why is this important, you ask? Well, a significant solar flare can interfere with our communication systems and even disrupt power grids. By predicting these solar tantrums, we can take measures to mitigate their negative effects, safeguarding our technology-dependent world. The future of solar flare research, therefore, lies in this predictive power and the protection it offers. As our understanding of solar flares grows, so too does our appreciation for the complex and powerful dynamics of our sun.